So I'm going to be talking about embracing Monolith, specifically in small teams. So I think there's a lot to learn in working in small teams, even if you don't really work in a small team. So it's going to be more of a philosophical talk and like how to approach some sort of problems. But there's going to be some code involved, just to show a little bit. So a little bit about me. I work at iScience. I started the company about 4 years ago. And we do sleep coaching for elite athletes. So our team, so teams, NFL teams, pro sports teams, they bring us on board to help their athletes improve their sleep. So everyone knows sleep helps you perform better. That's sort of like, there's a lot of research to do that, but no one really knows how to help people sleep better. So obviously athletes are super concerned about their performance and they want to do everything they can to sort of like be better. And sleep is one like fundamental aspect of that. So they sort of like bring us in to help their players in a way sleep better. And a little context of sort of how we actually work is that we go into a team, we give everyone a sleep sensor, goes under your mattress. We don't make the sensor, it's like an off-the-shelf sensor. And then we actually gather a lot of subjective data about what kind of sleeper you are and what your behaviors are. And then through that, we basically get sleep data every single day and slowly develop a recommendation system for you to give you a plan that's slowly going to get you to sleep better over time. And we do a lot of, there's also like a human in the loop because obviously we try to automate most things, but sleep is so personal and we deal with so high-touch users that often we need to have like a human expert involved in the system. But everything is delivered through our mobile app. And through the system, we've shown through some experimental studies that people sleep about 54 minutes more on average when they use our system. So it's a lot of sleep science and behavioral science and not a lot of like hardcore machine learning. It's more about applying what we know about sleep science and behavioral science and how to slowly help people improve. So we sort of have like two main product goals. I like to think about it this way, where in one side of things, it's about sleep improvement, both objectively, can we get people to sleep longer? Because we know generally sleeping longer is better. And then subjectively, do people feel better after sleeping? Do they feel they're getting more rest? Do they feel less tired over time? And then user enjoyment, right? Our product is through an app. And at the end of the day, we want them to keep coming because that's like the main way we can determine whether they sort of like enjoy using the product. And we need to iterate fast. So I said our company is about 4 years old. We've been full-time about 1.5 years ago, the three of us, and now we're 4. So we're a very small team. And we measure sort of our progress, like long-term is months, but usually we're talking about weeks and even days at a time. So speed is something that's very important to us because as a young company, we need to be proving our product. And there's an interesting aspect there being sort of in a very young company where you're often selling something that you don't have, but you know you can build it. So when you're sort of like making a commitment about something you can do, you need to be able to actually deliver that in time. So data is core to our product. So I like to think about two sort of companies where on one end, you sort of have companies that data enhances the product. So think about e-commerce. A lot of e-commerce companies, they're selling t-shirts. There's a lot of value in selling t-shirts and people just gonna go for that to sell t-shirts, but they can use data to make that better. They can, the usual recommendation engine to recommend you better t-shirts that are personalized for you. So that's sort of an example that if you take the data sort of system out of it, the product still works. Then you have other companies like us where data is sort of like the centerpiece of the product, and without data, sort of like there's nothing to do. So that's a screenshot of our app when there's no data. So sort of like it's pretty lonely. There's nothing to see. You see no data. You see no recommendations. So sort of like data needs to be there and it needs to be fresh every single day. that data that's actually matters to you and relevant to what you're going to do that day. So how do we actually develop the product? So to understand sort of like why I really like this monolith architecture, it's important to understand how developing product works, because at the end of the day, you're sort of like developing something and working through like a process, and you need to make sure your tools are sort of adapted to the process. So usually things start with a hypothesis, right? So it springs from domain knowledge, us being experts about sleep, or us talking to experts about sports science and how both match. Or it can be as simple as talking to users, right? Like what do they want to see? What kind of new things they want to do? And it can be as big as sort of like a new version of the app, a new feature, or it can be as small as, hey, we want to improve the data quality by 5% to make sure that there's some edge cases and we get those right. Usually then there's some exploration, right? You have some data sets available, maybe you can collect a little data, you can talk to some users, and you sort of want your tools to help you explore before you actually get into the experiment phase, where you try to come up with solutions, try different ways in very cheap methods to try to see whether there's potential in this solution. And then after that sort of succeeds, you get to a point where, okay, let's actually productize it and make it part of the product. Now you sort of need a lot more automation, a lot more reliability in your system, because now it's going to be sort of a standalone part of the product. And then after that, you sort of need to keep going, and you need to evaluate what you did. Oftentimes, you need to make reports from that. You need to analyze how people are using your product, where it's falling short, and so on. And then ideally, after you do that, that's sort of, after you keep evaluating and analyzing what you already shipped, you can then bring all those ideas back to generate more like hypotheses of new steps to work on. So that sounds easy. It's sort of like a very linear path, ideally. But then in practice, sort of like it just doesn't work that way, where you get into a roadblock and sort of like you're stuck because you don't have data or you don't have access to things. So you can spend months sort of like running experiments and you fail, or you try to productize things and it doesn't really work the way you expected it to. So there's a lot of obstacles in sort of like getting from this idea, oh, it's so awesome, let's make this feature, to actually getting it out there. So I want to go over a few of those. Data silos, where nowadays where there's a huge move to the cloud and sort of like using third-party solutions, you sort of have data scattered everywhere, right? So even as a small company, we have data internally that can be scattered even if it's in the same database, and then you have data in a bunch of other like third-party solutions, right? Your customer service product, your texting product, your sales and marketing product, right? So you have data in all these separate places, and oftentimes when you're trying to ask a simple question, you realize that you need to spend a week sort of like getting the data together, right? A few weeks ago, we wanted to know whether people that have better data quality coming from their sensor are more likely to use a certain feature. That sounds like a perfectly like simple question that you for sure want to be able to answer, right? Like, does this thing that is a core data make people use this feature more? But I had to spend like a full day sort of like getting data from Mixpanel, which is our user analytics platform, and then sort of like joining that in Python world with like our actual like data quality metrics, right? So it's sort of like any single thing you need to do very specific sort of like solutions because your data is in a bunch of different places. You also have problems with different tooling, right? As you move from exploration into more like productizing things, your tooling often changes, right? How many of you here like start working with like R and then sort of have to move into either Python or Scala when you're confident that that's also the solution you want to go, right? That's a pretty common approach, and oftentimes you end up repeating yourself. Okay, you do this quick thing in R, it seems to work, but you were pulling it off of CSV, and now when you need to productize it, you sort of like need to talk to a database. You actually need like actual latency concerns, like you cannot wait 10 seconds to read the CSV because it needs to be under 500 milliseconds latency. So you sort of like, as you move towards the product development cycle, you need to change your tooling. And there's a lot of overhead in doing that. Then you have people, right? We all work with people because you cannot really achieve great things without great people. And oftentimes, different people own different parts of the system, and people have different opinions. So you spend a lot of time as you move towards some steps. Like maybe there's people that are focused on the exploration phase, and then there's people focused on the implementation phase, right? Oftentimes you see like the data science team sort of come up with the models, and then the software engineering team has to sort of implement that. So you have that disconnect there, which causes a lot of just overhead in communication, really. I'm going to talk a little more about that. And then the most fun of all the problems I find through the product development cycle is when you sort of have something working, it works locally, it works in staging, life is great, you're super excited about this new fix and this new feature, and then you throw it on production, and you get alerts at 2 a.m. that something is broken, right? That's just a feeling that really sucks, as you wake up and you're like, wait, it worked perfectly everywhere, and now it doesn't work where it needs to. And there's a lot of reasons why that can happen. Here's a few. One, so I come from a software background, and there's this fuzzy and warm feeling around testing software that I really like, where if something is really important, you can actually do like comprehensive testing around like all possible scenarios and know that your software is sort of like right. With data products, often your code is perfectly right. What you did is actually work, but oftentimes it's sort of like a box that has some assumptions, and then in production, something might change, and then if you change data, for example, garbage in, garbage out, if you depend on a third-party data provider, like we do, and you have an assumption that for the past 4 years they've done the same like sample frequency for time series, and then they decide to like change that overnight without letting you know. Then your whole modeling system might break, and then whatever you did now is going to be different because they changed the underlying data. So oftentimes you have sort of these things that are out of your control because you cannot really know all the assumptions of the system. So testing data products often becomes really hard because you don't really understand all the data that can potentially come into the system. And then you have the usual capacity problems where somehow making things from staging to production and doing 10x the capacity now actually creates some like weird side effects in your like modeling, and everything takes way longer, which breaks the whole pipeline system. Fun things. And all these problems sort of cause you to delay and extend the product cycle. Like getting from idea to actually shipping and evaluating the product, that's going to take longer. And that's what you should be actually making shorter and shorter. So how do we start? How do we sort of like fix that problem? Obviously, with data stuff, the first step is you want to do some before you get into any modeling. You want to do more descriptive, some visual plotting, just understanding what you're dealing with. That's usually like the common approach. But often I find that it's important to like step back a little bit. And before getting into like writing code and looking at the data and looking at charts and distributions, it's important to understand what the organization actually needs. What's the problem that we're trying to solve? What's the higher level motivation behind our problem? Before focusing on the solution, which is, oh, I need to like look at the data and find descriptive statistics. So we're all part of bigger teams, and understanding like what's driving me and why people ask me to do something is super important, because often you can find sort of like other things that you were not asked for. And I think the reason behind actually stepping back and how I find that so important is that when we start with the solution first, the focus is on the tech trade-off, right? You already want to do something, and you have a few ideas of how to do it, so now you start debating whether you want to use this tool or that tool. Do I want to use R or Python? Or should I do it in a different language? Or which library do I want to use? So you focus on the tech trade-off. When you start with the problem first, you sort of like have the idea of how do I make progress towards solving the problem, which should be what we're working here, right? We're trying to solve the problem and not necessarily have a nice and fancy solution that doesn't really solve the real problem. So as a co-founder and also the lead developer of our company, one of the biggest struggles is that I need to balance sort of like the business values and the business objective with the technical things that we're doing, right? So oftentimes I want to do this like super fancy solution that I know is technically a better approach, but I need to say, hold on, I'm the co-founder, like the business doesn't really need that solution yet. It might be too early. It's not so, we're not so sure that we need that long term, so why invest in sort of like developing that structure? So as you sort of like get into more technical solutions and you try to get more and more optimality in your technical stack, in your tech stack, you actually sort of, you might end up decreasing your business value because you may want to do something that's 100 milliseconds of latency. And then to do that, you need to like invest in a lot of complexity to make that fast enough, which means that later down the road for the business, if you want to change something, it's harder. So now what you did, which was a better technical approach, you did something faster, made your business harder to change, which is one of our goals. We need to be able to change a product fast. I love this quote by Jason Fried on, so when you say no to one thing, you're just saying no to that specific thing. But when you agree to something, you're sort of like saying no to everything else. And I think that applies perfectly here. When we want to do really good at a technical point, like making this thing super fast or super accurate, we're often sacrificing some other things, like not spending time doing some other thing. So I usually start with sort of like that question, what's the least I can do to solve the problem? Sometimes I feel like I'm just too lazy and I'm just like sitting there in my computer like, am I really thinking this? Like I don't want to do work or what? But I find this super helpful because personally, and I know a lot of my friends in software and data, sort of like we like using new tools, we like fancy things. So oftentimes all we need is like a good excuse to try this new library and this new algorithm, because why not? Why not try that? Why not try TensorFlow if you're trying to do something? Why not try Spark if it's really cool and people like it, it's shiny, like I want to play with it, so why not do it, this solution that doesn't really need that, but I just want to use it. So I think it helps me, asking these questions sort of like puts the question in my mind and it helps me counter my bias against sort of like using new and fancy tools just for the sake of checking them out. So we need an architecture and we need a set of tools and frameworks that are compatible with how we want to operate and how we want to like approach the problem. So here's where the monolithic architecture comes in. So from the software world, and in 2016, this is a lot of people are debating about it. I like a lot of the work from Martin Fowler. He's a great thinker on software practices. And he describes a monolithic application as one where like all the moving parts are in just one process, right? So you have that box and you have the red circle, the green little triangle, and like these are all functionality and they're all in one process and literally one code base. And then when you need to like scale up, when you need to do more of that, all you do is copy that same thing in multiple servers. And that's how you sort of get scale. Whereas the microservices approach, you sort of like break every single piece of functionality into their own services that are fully isolated and independent. And when you need to scale, you can just mix and match whatever you need. So you can put 2 of these little services in that server, and then 3 of those services in that other server. And sort of like if you need more of the login authentication service, you can just spin up more of those services. And you can have a whole team inside your company manage one service. So you don't really get a lot of, you don't need to like coordinate with every single other team when you're doing something. So here's a great chart on sort of like the trade-off between 2 approaches. On the x-axis, you sort of have the base complexity of operating something, of your code base, of your product. And then on the y-axis, you have your productivity of your team, of your company. right? The green line is the monolith, where you start off and you're very productive, right? Because everything is in one code base. Every single thing, you sort of know how it works. You can put it in your head. You can look up the code in one sort of, everything is in one place. Everything can talk to each other much more easily. But as you sort of move to the right and your thing gets way more complex, way more moving parts, then your productivity sort of like drops drastically, because now every little change, you need to make sure that it sort of like doesn't break the whole world and it's touching a lot of parts. So that's dangerous. So as you get more complex, you sort of get more risk averse and you don't really want to touch things because you don't know what side effects there are. On the other end, sort of on the microservice, the blue line, you start right off the bat, you're less productive, right? Because from day 0, you sort of have 10 services. You need the login thing, you need the predictive model thing, you need the data ingestion service, you need the login service, so all these services. And just to make them talk to each other, there's a lot of overhead, right? Usually you have one team or a set of people manage one service, so just to get like a new thing, you need to coordinate between a whole set of teams, and it's not all in one place. But as you get more and more complex of your product, then when you own one service, making changes to that service is much easier because you don't really depend on everything else. You can just make changes and you know sort of like what contract you have with other people and with other teams and with other services. And that you can be more confident that you're not going to like break the whole world by making a little change. So over time, as organizations get more complex, doing microservices is often the right approach, right? Because you grow too big that there's no way you can sort of manage everything into one monolith. There's few exceptions, but a lot of big companies have moved towards a microservice kind of approach. So Django. Django is, who's familiar with Django here? It's a web framework. Okay, great, a lot of people. So it's a web framework. It makes doing a lot of things that require like web needs super easy, like having a server, having API, having sort of like forms and validation and logging and all of these things that everyone needs, it's put in one place. It's probably the biggest Python web framework. And the reason I like it is that it has a lot of built-in tools that I don't really have to worry about. So I want to go to a little bit of those. So besides the built-in tools, it's super important to like reuse libraries that are out there, right? That tweet was great. So the hardest problem in computer science is fighting the urge to solve a different, more interesting problem than the one at hand. How often, like, I'm working on a problem, there's this great library that does 60% of the job, and I'm like, wait, I want to do this library better because I can, and I have this specific set of needs, so why not just do it myself, right? It's a fun challenge. So you sort of want to work on these like bigger, more complicated problems, and you can sort of like sidestep from what you're actually trying to solve. So in Django, you can integrate super easily with your IPython set of notebooks, right? So we manage a Py, that's sort of like the Django utility to like do anything Django related. It has all the scripts in there. And you can spin off a notebook, IPython notebook, with simply that command, and then you sort of like bring up a whole environment where you have your whole production code, your whole stack that you're already using for sort of like moving data around and validating data, and you can use that for exploring data from like the data side, from the data science side of things. So one of the funny things that we love, the data community, we love complaining about how much time we spend like cleaning and wrangling data, right? We spend all this time cleaning data, getting it to the right place, and then like 1% of the time is actually running the fun stuff, the models. Well, it happens that sort of in the software world, it's about the same, right? You spend all this time like validating data, making sure that the form data that you get from API is correct, making sure that date times are formatted properly, so making sure that the user IDs are formatted. So all of these things, you spend all this time validating and wrangling data from the software side. So when you spin up and you try to do sort of like the data science stack, and you have access to your production backend setup and code base, you can sort of like reuse a lot of the tooling. So it's really cool when you can start doing some exploration and you can just use the same code that already is in production to sort of like get that data and clean it for you. So you sort of like get that for free by being all in the one code base. The ORM, so the ORM is the part that matches, sort of like maps the database to your Python objects. So when you're sort of like developing software, you want to have these like nice little objects that contain your data, and you can like tell them to do things and ask questions to those objects, right? So for example, we have a big table in our database that holds all the sleep data for people. And that table, it's big. It has a lot of interesting sort of like computations that we can do on that table. So all the time, we're just like piping data from that table to, we want to do something with that in the data science side of things. So early on, we would usually just dump the data into CSVs, pipe it into like, load it in R and do everything in R. But then slowly realize, wait, I can just load this up through Python, and I can ask it a question and start working on the same data science stack inside my Django code base, inside IPython, because I basically get very similar tooling that I get in R. So for people that don't really know the Django query language well, this basically all I'm doing is saying sleep, that's my table, get me everything that matches that filter, and that filter is for the person ID 1, which can be my ID, and has a sleeping date that's greater than or equals, that's a double underscore, August 1st, right? So that double underscore is actually a really great feature of Django. I don't know how many of you actually know how to query Django, but it basically allows you to do like arbitrary joins and operations on your queries that are fully dynamic, right? So I have the sleeping date that's a column, and I can just do double underscore and tell it greater than, and it's just gonna basically translate that into that SQL query to my Postgres, and it's just gonna select all the columns for my sleep that I need, where the person is 1, and the sleeping date is is later than August 1st. So that sort of like does that for you. So you can use all your production queries that you already have in Python to pull data into your like data science and exploration phase. There's a few tools. Obviously, Pandas is great when you're doing data moving around and you want to model stuff. So there's a few ways of doing it. My preferred way is the Django Pandas library, which is really a thin wrapper around pulling data from the database from Django into Pandas. So you can tell things like just read frame, and it's going to automatically go to that query, pull data from the database, and just get that into a Pandas data frame and do all the right conversions for you. So it's sort of like super easy. In one line, you're asking the thing to do the query for you, do all the conversion into Python and Pandas, right? You don't have to worry about getting data from the database into like a nice usable Pandas frame. And for example, in this case, I want to find how much I'm sleeping by day of week, right? A reasonable question that one time I actually wanted to know for part of a product. And I can probably write that in SQL. I can maybe get the full table and then do the whole thing in Pandas. But by sort of like combining both, you can mix and match what things SQL is good for, what things Python are good for, and what things you sort of like need to just write some manual scripts. So, with this super simple example, I'm just like in 3 lines, I'm sort of like getting the data from the database through my Python query, through my Python backend code, and getting into something that I want. Another benefit of the instrumentation, another benefit of the monolith is that we sort of have instrumentation sort of for free. Like I'm already doing instrumentation for my backend code, so I can use the same tooling to sort of know how my data science stack is performing. Right? This was a few days ago when we rolled out a new model, and the latency of that model went super high because it was way more intensive computation. Right? I didn't really have to do anything because my backend was also already tracking sort of like all my system. Right? So I sort of get that for free by integrating everything in one code base. So I want to talk a little bit about the people and how that sort of like creates challenges in the product cycle. So there's this idea that I read in a great book by some Google engineers. I forget to put the quote here, but how toil, which is like a very mechanical, repetitive tasks that are often boring, can create sort of like a negative culture, right? You have people non-technical people that want data. So they ask engineers of the data team. And that sort of like takes time because engineers are busy doing something else. So people slowly stop asking data because they feel bad about asking the engineers and wasting their time. So over time, you sort of evolve into a culture where people don't want to ask data because they feel bad about bothering engineers or it takes too long. So I think one of the main ways of sort of like bridging that gap is by trying to move towards like a self-serve analytics where everyone in the team, in the company, is empowered to get access to the data and answer their own questions. So one of the main ways of getting there, the first step is sort of like breaking the data silos, right? Getting all the data that I was talking about in one place and centralizing it. So for the sake of time, I'm going to skip this slide, but centralizing data is super important if you want to be able to sort of like give self-serve analytics to all your people. In our case, we sort of like pipe all the customer data from like app usage and client-side analytics through Segment, which basically aggregates everything for us, and that they dump it into a database for us. We also have our backend Postgres server, and then through a super simple company called Stitch, they basically just copy over all these data sources and pipe it into Redshift. It's literally like a one-click setup. I don't have to do anything, and I have like a super nice production copy of all my client analytics and backend data into like a Redshift so I can actually query and run dashboards against. So why is that awesome? Because I basically get it for free because Redshift is basically Postgres, or at least it has the same interface. So I can run a query like this, which I'm aggregating like a huge table of over 100 million rows to find the average heart rate of a team, right? So in Postgres, that takes over 200 seconds, whereas in Redshift, that was super quick in 4 seconds. So by getting that sort of like difference in time, you sort of like give yourself a chance to ask bigger questions because you don't have to wait too long, right? When you have to wait 200 seconds, you sort of don't really want to do it because you don't want to context switch and wait for the thing to finish. And the great thing is that it's almost compatible with Postgres out of the box, right? So you can basically use your exact same Django code that you already have and just switch the underlying database, point it to Redshift, and run the same backend that's now for like analytical queries is going to be much, much faster. In this case, there is like a one little change in the code, but usually you do that in the config, so you don't even have to do any code changes, and it mostly works. There's some little problems, especially if you're using like Postgres-specific data types, but generally it's pretty good. The last point I want to make is about bringing data to the people. We're obviously working with people, and oftentimes they have to go to different places to get data. They have to go to Mixpanel to run queries. They have to go to our admin page to like figure out some data stuff. So I find it super helpful to bring data to the people and bring it to where they are. So obviously we're heavy users of Slack, and we sort of like end up piping everything into Slack and make it super easy. So Slack makes it really simple to write custom integrations. So for example, we did something that anyone in the company can do /report and put the report name that they want, and our backend is just going to pipe it into Slack. It takes literally 10 lines of code in Django to do that, and it gives all the non-technical people a lot of power in just getting this report whenever they want on their phones or on their computers, right? So you don't have to sort of like do a complex solution. You can just bring it super easy to where they are. You can also push data to the people, right? You don't have to wait until people want data to give it to them. If you know someone is in charge of the customer service and there's sort of like we have a lot of problems with Wi-Fi as well, since our sensors connect to Wi-Fi. So if there's a problem with Wi-Fi, we can just tell the customer service people and say, hey, check out the sensor, it's not connecting, right? Instead of waiting for that person to sort of like decide to open up the monitoring dashboard for Wi-Fi errors. So it sort of like creates that positive feedback loop that people are encouraged to ask more and more questions because they have access to data and they don't feel bad about bothering the engineering or data team about wasting their time. And that way the engineering and data team can then focus on getting better and better tools for the people to get their own data. And obviously, it's hard. It's like an ambitious goal, and often it's hard to get there. But we should strive into making it a self-serve as much as we can. And the last point I want to make is sort of like be scrappy. And Python is an awesome language. A lot of libraries to be scrappy, and often you don't need that super fancy new thing to do it. When you can just maybe spin up a bigger AWS EC2 machine that has 200 gigabytes of RAM and quickly run an experiment, right? That might be way quicker and way cheaper than spinning up a Hadoop cluster in Spark. So oftentimes being scrappy and having that mindset gets you there much faster and helps your team. Thanks. Any questions, if we have time? Yeah. Yeah, so in Monolith, I argue the main thing for us is that we're a small team. We don't need the complexity of a service, because when you're in a service, you sort of have a lot more complexity in managing and orchestrating all these independent services to talk to each other, right? Just keeping them talking to the same version and making the deployment strategy work at that point is a huge pain, right? I talk to my friends in big companies, and when they're at that point where there's a lot more moving parts, it absolutely makes sense, and it would be the wrong decision to do a monolith. But in our case, when we're a small team, we understand where we are, and that's where sort of like using this monolith, that everyone sort of like understands the whole system. Yes, it puts a lot more pressure on people because they need to understand the system, but they also take more care of the system because now they're going to be touching every part, and they know everyone else is going to be touching the whole system. So they sort of like need to put effort into keeping the system nice and tidy. Does that make sense?
It does. I totally agree with you, but I always hear this. I take that side of the argument too, and I always hear, but Docker, but Lambda.
Yeah, I mean, just spinning up those things often take a lot of time, and it absolutely makes sense. I think one of the things that the monolith gets like a bad rap is that it makes it super easy, and I hate, in theory, I don't think there's a fundamental problem, but in practice, it makes it super easy to sort of like cross your boundaries and write crappy code by touching part and by not keeping it modular. Whereas in microservices, you don't even have access to the other like classes in your system, so you're forced to keep it modular. Whereas in the monolith, you sort of have to be much more self-disciplined and say, hold on, this is getting, like this class, this object shouldn't really be talking to that object, even though it's in the same code base and I can import it. So I think that's a problem, and it brings a lot of the discipline into the developers in saying, no, I'm going to respect the modularity of my code and keep it clean. Yep.
So if you're a small company starting out, but your intent is to grow, there's probably going to be some point at which microservices makes more sense. But how do you evaluate the switching cost versus starting out and like taking the productivity hit? So do you start with the monolith because you're small, and then eventually switch, or not?
Yeah, I mean, that's a great question. Yeah, so the question is that we're a small company, and as we grow, it probably is going to make sense to switch to a services architecture because, as I said, bigger teams usually benefit from a services. So the question is, how do I think about starting as a monolith and then deciding when the switching cost is going to be better? Is it going to be worth it to transition over? So the quick answer is that that's a question that we have. Because obviously, as you invest more and more in the monolith, sort of like it makes the switching cost higher and higher. But since we're a small company, most of the code I've written, actually, we sort of like don't even use anymore, right? Because we're always iterating on the product, new features, trying new things. So I think part of the answer is that as you sort of grow enough, you sort of can identify like a few key parts of your system that are maybe really high load. And maybe those are the few things that you can start taking out of systems, extracting out, and then you sort of evaluate how that process works and slowly start taking pieces out into services instead of sort of like saying, I'm going to rewrite the whole thing from scratch in services. So that's my approach, and I actually started doing a little bit of that. Our predictive model that we use is actually an independent service that it's still in the same code base, but it's managed by like a whole different deployment setup. So even though it's in the same code base and I can use the same code, it's sort of like deployed to a different place and has a different orchestration setup. Yeah.
How people can request or resend reports, but what do those look like?
Yeah, so that's where we actually have to build it. So the question is, I show you how people can, through Slack, just get a quick report that they want to do, right? The customer service people can get, the customer engagement data right there in Slack. So how do they actually look? They're basically like a table of text. Sometimes you can pipe in through IPython, since you have it in your code base, you can generate an image and just pipe it through Slack. So you can actually send a chart of engagement data through Slack. There is quite a bit of like manual work in getting the reports going, like actually formatting it properly, and you still need to actually get the queries. But oftentimes those queries that you need for reports, you already have sort of for your production data. So it's just moving data around and doing the right formatting. So most of the time for us, it's just literally text and like names of customers that customer service needs to interact with. Any other questions? Thanks for coming. Appreciate it.